Hello friends, welcome to today's Apache Spark session. In today's session, I'll be discussing about RDD concept and some programming perspective on RDD. So before going into detail, let's have our agenda first. So today we'll be discussing about RDD concept, phases of RDD and coding knowledge on RDD. Now first let me discuss what exactly RDD is. It stands for Resilient Distributed Dataset, which is a fundamental structure of Spark. Now let's check what exactly every word of this full from. First is resilient. It is nothing but a fault tolerant of collection of data. It means RDD can be recovered from node failure automatically. It is distributed. It means RDD does parallel processing of distributed dataset. Now dataset is RDD divides each dataset into logical partitions, and it is read-only based collection of data, and all types of Python, Java and Scala objects including user-defined classes can be processed with RDD. So these are the three definitions meaning of this RDD. RDD is an immutable distributed collection of objects. What exactly it means? It means it can be recreated again if needed. This is one of the most advantage in RDD. For example, if we create first time RDD and then if we have to create RDD as per our requirement, then we can take the initial RDD and we can do as per our calculation on requirement, and we can do it accordingly by taking the first RDD. Now in RDD, transformation and actions are conducted on a stored data set and sometimes on group of data, group of RDDs and also another RDDs also. As RDD persists on memory, that's why it enhances data processing speed across multiple operations, and that's why it enhances the data processing speed compared to Hadoop. Because Hadoop is an on-prem system, but in RDD in Spark occurs on memory only. That's why it is much more faster compared to Hadoop. Now persistent RDD makes a node in such a way that it stores its transform data in its partition memory only to quick the reuse of its other action. As all the transform data are kept in memory only, that's why very easier to reuse it. If it was used in a disk, then it was very difficult and it was very time consuming to take the data from the disk and process the data. So as it is persist on memory only, so it is very easily reusable for the other action. Now there are two ways to create RDDs. One is parallelizing an existing collection in your driver, and another is referencing a dataset in an external storage system such as shared file, HDFS, HPS, any other data source file. So I'll be showing you by two ways for creating the RDD by giving the example. So for showing that, let me open Scala. So here I have installed one software for testing purpose. If you'd like to go for hands-on from the basic level, you can use this software. This is very useful for Spark Scala learning. I'll be giving you this installation link in my description box. You can check it out and you can do from in your machines. So first I'll be showing you what exactly and how parallelized way RDD can be defined. So I'll be defining one set val data equal to array 1 2 3 4 5. So here if you see, I have defined one RDD named data. In that data, one array is defined. Now how RDD can be created by parallelizing way, that example I am going to show. So I have to define one new RDD. For example, this data equal to sc dot parallelize data. So this data is nothing but the previous RDD, which is taken here as a parallelized form, and this SC is nothing but a Spark session. If you see here, Spark context available as SC. So when Spark context is defined and we write the Spark cell, then automatically SC creates as a Spark context, which will be helpful, which will be useful for using in the further coding. That's why I have used val this state. This is a new RDD equal to sc.parallelize data. So by using this way, you can see this is the form, this is the way by which RDD can be initialized in parallelized way. Now next is referencing a dataset in an external storage system. This is also another way of creating RDD. So how by referencing a dataset from external storage system can be done by for creating the RDD, that's what I'm showing you now. For that, as I'm using Ubuntu operating system, so first we have to know what the path exactly, so that we have to check the file and then only we can able to read the file and we can do the different access. For that, I've opened another Ubuntu terminal and I see what exactly path is. Now within this path, I have created already one text file, that is data.txt file. So in data.txt file, I can show you what exactly contains. Here it is, hi, this is Apache Spark session on RDD. You will be learning from basic level. This is the content of Spark. So now what I will be doing, this data.txt file will be fetched in Scala, because here what I have mentioned, this RDD can be created by referencing a dataset in an external storage. So this is one of the path from where data.txt file will be fetched and it will be creating the RDD. So now how RDD will be created for using data.txt file. So I'll be creating a new RDD, val dist file equal to sc dot, as I am reading the text file, so I have to write the text file function, text file data.txt. So this is the way by which we can reference a data set which is present in a specific path of a file, and then we can use by sc.txt file for creating a new RDD dist file. So this is the second way of creating Spark RDD. Now coming to the another point, Spark RDD has two phases, that is transformation and action, which I told you that I will be discussing now. Transformation is the phase by which different calculations are happen, and we can manipulate different calculations by using different functions in this phase, and then we are providing this output to the action phase to give the further work. So there are different transformation functions are there. Those are map, flat map, filter, group by key, reduce by key, and many more. Now coming to action phase. Action is the phase where basically data are collected from transformation and it gives the output to the end system. That is the phase of action. So in action phase, basically it collects the output from transformation and gives the output to the end system. So different examples of actions are reduce, collect, save as text file, and many more. So now I'll be discussing about some function of transformation so that it can be easier for you to understand and go for further details on that. So for transformation, let me go to Scala code first. What I'll be showing you the concept of map, flat map, and also this reduce by key. These three functions I'll be discussing, so that you can have some idea what transformation exactly does. So for defining map, what I do, I'll be creating one new RDD, that is counts equal to this dist file is the RDD which I have to point. So dist file dot map word comma 1. Oh, I have given one wrong thing. Map word. Okay, so let me show you what output I'll be getting after doing this map function, so that it can be easier for you to understand what exactly map does. So this map is a transformation function, and I'll be doing this save as test file as a action to get the output. So counts dot save as text file. Let me give the name of the output map output. So let me check on that path whether this has been created or not. So if I see, this map output folder has been created. Now let me go to that one. There are two part files are generated, part 0 and part 1. So what exactly those part file contains? This one is one of the content, and now go to second content, this one. So from this output I can say you what exactly map does. So here if you see in map function, it will be what it does, it is showing you the count of number of rows. So what exactly it does, in every line present in that file, if you see that file, that hi, this is appeared one time, it is considered as one row. This is Apache Spark session in RDD concept, this is second row, and you will be learning from the basic level, this is the third row. So all the row, each row is considered as a key, and the number of key is 1. It means this row is appeared one times, that's why it is considered as a 1. So the main work of the map is it divides the data into key value pair. So high is the key. If you see here, high is the key and 1 is the value. It means high key is appeared one time. And this is Apache Spark session on RDD concept. This is one of the key which is appeared one time. So like this way it is showing the output. So the main fundamental concept of map is it divides the data into key value pair, and it gives a corresponding value of that key result. That is the main work of the map. Now let me show you what is the purpose of flat map. So I'll be defining one I'll be using flat map. So this file dot flat map line dot split okay I have DDD and define val. Okay, so now let me see what output I'll be getting here. I will be renaming it as a flat map. So let me go there. Flat map. What exactly part file contains. And part 1. So let me tell you in flat map what exactly it does. In flat map, every line it will be splitted whenever it will find the space. So if you see here, after high there would be space, that's why it divides into new line. So every time whenever it finds a space, it divides into new line, and then all the data is divided into two part file, part 0 and part 1, and it is showing the output. So that is the output, and that is the function of flat map. Means it is flat, it flattens the data. That is the work of the flat map. Now another transformation function which I have mentioned here, that is reduce by key. Let me show you the work of reduce by key also. So for using the reduce by key, I have to use map and flat map both, so that I can show you that one. So here dot map word comma 1 dot reduce by key. Reduce by key. So I will be saving that data into one file, that is all. So in this file, here also two part files are generated. Those are part 1 and part 0 and part 1. So these are the two files has been generated. Let me tell you in brief. If you see this example, that is flat map, and then reduce by key. So the work of this one is, first it has to flatten the data by whenever it finds the space, it flattens the data. Then as per the word, it counts how many keys are present. If you see here, first it flattens the data, means after concept it finds a space, so it divides into new line. Then as I have used map function, so this concept word is count as a key, and the concept is counted one time only, so that's why it is appeared as a 1. So like this way, after doing this operation, all the things are done in reduce by key, means all the data after doing map and flat map, it is collected and it is saved into two files, part 0 and part 1 file. So that's why by using this, after using reduce by key, we are getting this output. So I hope you understood what is map, flat map and reduce by key as a part of transformation function. And the save as text file, as I told you, this is the action phase. So for action, I have given you this example, and let me show you this collect statement also, so that it can easier for you to understand what action phase does. save as text file, I hope you understood that it collects the data from transformation and gives the output. It saves the result in a specific file and then shows the output. So now I can do counts dot collect. So this output is like that. So if we'd like to see that in functional format, we can see here. So whatever the output you have seen in this all flat map output folder, this is divided into part 0 and part 1. This entire thing you can able to see by using this collect statement. So that's why we can say this is collect is a part of action phase where it gives the output to the end system. So I have discussed all those map and flat map and corresponding examples by giving some programming logic. I hope you understood. If you have any doubt on any of this logic or any of the functions, please let me know in comment box. I will definitely reply. So thank you so much for your time, and please do subscribe if you like the video. I'll be coming with much more video on Spark and much more big data concept. Thank you so much. Thank you. Have a great day. Bye.